How is electrical grounding handled in hospitals? When it comes to hospitals, electrical grounding is a vital aspect that ensures safety and reliability. Hospitals are unique environments where patients, medical staff, and sensitive equipment all coexist. Let's break down how electrical grounding is specifically managed in these critical settings. Grounding is all about providing a low-resistance path to the earth. This helps safely dissipate fault currents and stabilize voltage levels. In hospitals, grounding systems are designed to protect both personnel and sensitive biomedical equipment. All conductive parts that could be touched by patients or staff are connected to a common grounding point. This minimizes any potential differences that could lead to electrical shocks. One key element is the patient equipment grounding point. All receptacle grounds and conductive surfaces near patients are linked to a dedicated grounding point. This point connects to the building's main grounding system, ensuring a stable reference ground throughout the facility. Isolation transformers are another important feature in hospitals. These transformers create isolated power systems, separating the secondary circuit from the primary power source. This setup reduces the risk of shock and allows the system to keep operating safely, even if a fault occurs. Line isolation monitors continuously check the impedance between isolated conductors and ground in critical areas. They detect ground faults early, allowing for maintenance before any hazardous conditions arise. Medical devices are classified based on their electrical safety requirements. Class I and Class I equipment requires protective grounding, connecting all accessible conductive parts to ground. On the other hand, Class Roman II and Class Triple equipment may not need grounding due to their special designs. Hospitals may use various grounding systems, such as isolated neutral, separate protective earth conductor, or combined neutral and earth systems. The choice depends on the facility's design and age. Modern hospitals often prefer isolated neutral systems for enhanced safety. To protect sensitive electronic equipment, separate grounding conductors are used for signal and control systems. These are isolated from power grounding but still referenced to the main ground to avoid noise and overvoltages. In practical terms, all grounding conductors must be sized correctly to safely carry fault currents. Grounding electrodes, like copper rods or plates, are installed based on soil conditions to ensure low resistance to earth. Regular maintenance and testing of grounding systems, isolation transformers, and line isolation monitors are essential for safety and compliance with standards. Critical areas such as operating rooms and intensive care units requiring specialized grounding designs. This helps minimize risks associated with microshock and macroshock. Conductive flooring and isolated power panels are often part of the grounding strategy for added patient protection. In essence, electrical grounding in hospitals is a well-structured system. It combines dedicated grounding points, isolation transformers, continuous monitoring, and equipment classification. This ensures a safe electrical environment tailored to the unique demands of healthcare settings. The goal is to safely divert fault currents, protect sensitive equipment, and shield patients and staff from electrical hazards.